Hi everyone, in this video I want to show a circuit analysis problem. So we've talked about how resistors can be put in series and parallel, but sometimes it's more complicated than that. In fact, for example, in this particular problem, I have a circuit here with two batteries, two power sources. I don't know how common that actually is, but this type of problem can pretty easily illustrate the Kirchhoff's rules, right? The junction and the loop rule that we talked about in the last lecture. So the goal of this problem, I've got a circuit with two batteries and several resistors here, is to get the current in each resistor, in each part of the circuit. Now, first type of thing you have to do here is actually choose the directions of the currents. It doesn't matter which way you choose them to be. After you've done all the math, if your current gives you a negative answer, that just means you chose it in the wrong direction. So let's first of all, let me show you. I'm just going to pick currents here, and this is a 5 ohm resistor here. And it got a little darkened, but I've got a 20 ohm, 10 ohm, 10 ohm, 5 ohm, and then a 5 volt battery and a 10 volt battery. So I'm going to just choose the currents, and I look at a junction and I realize, okay, I've got current going in and coming out. So let's say the current going into this junction here is I1, then I have a current I2 going out and I3 going up around this 10 ohm resistor. Now to realize, what you have to realize too here is this current I1 is the same through this whole left side. Right? It comes out of this junction, I2 goes in, I3 comes all the way around, and it goes back in down here. So I only have one current over here. I have I2 going all the way down the middle and I3 all the way around the right-hand side. And the goal is to get those three currents, I1, I2, and I3. Now the junction rule says the current going into the junction, I1, has to equal the current coming out, which would be I2 plus I3. So right there, I've got an equation relating my currents. Now to get more equations, analyze the circuit more, I've got to use the Kirchhoff's loop rule, which says that the voltage gains and losses going around a closed loop, any closed loop in a circuit, has to add up to 0. So first of all, let me talk about my mathematical goal here. I want to solve for all three currents. I need two other equations. And the way I'm going to do it is I'm going to try to get an equation for I2 in terms of I1 and I3 in terms of I1. If I get those equations, I plug them in, and I've got an equation with only I1 in it. So that's kind of my starting point. So let's look if I can get an equation with I2 in terms of I1. Well, if I look, I can see that I can go around this left-hand loop. All right, the left side and then through the middle. I3 is not in that part of the circuit. So I'm going to start behind the battery here. As I go across a battery from negative to positive, it's a voltage gain. So I've got a plus 10 volt gain. As I go across a resistor in the direction of the current, it's a voltage drop or a minus. And using Ohm's law, voltage is current times resistance. So across the 20 ohm resistor, I've got a minus I1 times 20 ohms. Now I come down the middle and I've changed currents to I2. I'm going opposite from positive to negative across the battery. That's a voltage minus or drop. So I've got minus 5 volts. Well, then I hit the 5 ohm resistor with current I2. It's going in the direction of the current. So it's minus I2 times 5 ohms. Then I hit the junction and I turn back into current 1. And I hit this 10 ohm resistor going in the direction of the current again. So again, it's a minus I1 times 10 ohms. Now at that point, I've come all the way back to my starting point. I've completed the whole circuit. So I have to set everything equal to 0. So at this point, I'm just going to simplify, right? I'm going to add the I1 terms. I'm going to drop all the units here just to make it easier to read. But there are volts and ohms in there. So 30 I1 here from these two. I've got 5I2 minus, just combining everything and doing some algebra, I see I2 is equal to 1 minus 6I1. All right, that's my first equation. Now I want to look for an equation for I3 in terms of I1. And so I'm going to go around the outer loop. I'm going to start behind this battery and now go all the way around the whole outside. Then I completely miss I2. So again, doing this, starting here, I have my plus 10 volt gain from the battery, minus I1 times 20 ohms from this resistor, hit the junction, change to I3. Now, one thing I noticed, these two are in series, right? So I could combine these to make a 20 ohm resistor. And so this is where I get my minus I3 times 20 ohms. Although, of course, it's the same thing as minus I3 times 10 ohms minus I3 times another 10 ohms, right? So I've got my I minus I3 voltage drop, 20 ohm there as I go around the outer part of the circuit. Now I come back and hit the junction again, and I'm back to the 10 ohm resistor with I1. So I have a minus I1 times 10 ohms. Completed the loop. I've gotten all the way back to where I started. So those have to add up to 0 according to the loop rule. Again, just doing some algebra, dropping the units. I have 10 minus 30 I1 minus 20 I3. Solving for I3, it's 1/2 minus 3 halves I1. So at this point, now it's just more algebra. I'm going to plug these two equations for I2 and I3 back into my junction rule equation. Right, and so that's kind of what I did here. I just plugged in 1 minus 6I1 for I2, 1/2 minus 3 halves I1 for I3. And then it's just algebra, combining the I1s, going through here. I won't go through all those steps, but eventually doing the algebra, I get I1 is equal to 3/17 of an amp, or 0.176 amps. Then, to get my other currents, right, I just go and plug this 0.176 back in to my equation for I2. So I get, well, I probably shouldn't round here. This should be 0.176, but I'm just putting 1 minus 6 times 0.176, or about 0.18 amps. I get a negative answer when I do that, negative 0.056. Now this tells me I drew I2 in the wrong direction. It should actually not be going down, it should be going up. Now that makes some sense because this 5-volt battery is pushing the current up. But again, it illustrates, it doesn't matter when I start the problem which way I choose the currents, a negative sign will pop out if I chose it in the wrong direction. Okay. And I can do the same for I3 to get current I3, just plug in my 0.176 amps for I1 and calculate, I get 0.236 amps. Okay, last thing just to check my answer here, I should have that these I2 plus I3 equal I1, right? That's my original junction rule. So if you add these together, you get about 0.18, which within rounding error does check out to obey the junction rule. So I can be pretty confident these are the correct currents. Now, one last thing, what if I did want the voltage across any resistor? Well, if I wanted the voltage across this 10 ohm resistor, right, I just take I3, whatever current it has, times its 10 ohms. Now I can calculate the voltage across any part of the circuit. In fact, if I wanted the voltage, let's say I wanted the voltage between this point A and this point B over here, well, I could do not a complete loop. I would just take positive 10 volts minus I1 times 20 ohms minus I3 times 10 ohms. And whatever number I got as I went through that part of the loop would be the voltage between A and B. Okay, so hopefully that will help with understanding Kirchhoff's rules and analyzing circuits a little bit. And in the next video, I'll talk about charging and discharging of capacitors.